The first part of the question asks you to determine the percent of each element in the mineral hematite, Fe2O3. What our strategy here is going to entail is finding the total molar mass and then figuring out the mass of each element as a percentage of that total molar mass. So if I add up Fe2O3, that'd be the molar mass of 2 irons and 3 oxygens, I get 159.7 grams per mole. To then figure out the percent by mass of iron in hematite, I would take the mass of just the 2 irons, which is 111.7 grams, put that over the total mass, and multiply by 100. To find the mass of the oxygen, I would take the mass of the 3 oxygen atoms, put it over the total molar mass, and multiply by 100. Doing this, I find that hematite is 69.9% iron and 30.1% oxygen. What's interesting to note here is that there's actually more oxygen atoms in hematite than iron, but because iron is much heavier, it constitutes a larger percent by mass. For question 2, I want to find the empirical formula of the mineral goethite, a common source of iron. To start with, I want to assume that I have 100 grams of this compound. Assuming that, my 62.86% iron would translate to 62.86 grams of iron. Likewise, for oxygen, the 36.02% oxygen would translate to 36.02 grams, and for hydrogen, 1.13 grams. My next task is to convert these grams into moles by dividing by the molar mass. This tells me that in 100 grams of goethite, there are 1.13 moles of iron, 2.25 moles of oxygen, and 1.12 moles of hydrogen. That gives a formula like this, which we know is impossible because you can't have a fraction of an atom. The best way to simplify this formula is to divide all 3 by the smallest number of moles. That would give me 1 mole of hydrogen, 2 moles of oxygen, and 1 mole of iron. And this is a formula that we could write. Fe1O2H. That's the empirical formula, or the ratio of atoms in this compound. You wouldn't be expected to know this, but in reality, this is probably FeO with a hydroxide attached to it.